day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwane. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Okay, grade 12, our topic for today, we will be revising number systems and algebra. Okay, after the completion of today's lesson, you must be able to convert decimal numbers to binary and binary numbers to decimal. And then you must also be able to add, subtract, multiply, and divide the binary numbers. Also to simplify exponential expressions and to solve exponential equations. To add, subtract, multiply, and divide cells. To simplify logarithmic expressions and solve logs equations. And then to solve quadratic equations by means of factorization and also by means of a quadratic formula. And then to solve quadratic inequalities and to interpret your solutions graphically. And then lastly, to solve equations with two unknowns, one of which must be a linear one, and then the other must be quadratic, grade 12. No more linear to linear. Now it is now a linear to a quadratic equation. And then you must also be able to manipulate formulae. That means you make your variable the subject of the formula. Sometimes we call this the literal equations, where you are working only with variables. And then you must also be able to determine and prove the nature of roots. And then you must be able to add, subtract, multiply, and divide your complex numbers. That means you will also be looking at the complex numbers. And then you must be able to represent the complex number on the Gantt diagram. And then you must be able to determine the modulus, of which is r, and the argument, of which is theta, of complex number. And then you must be able to express a complex number in the polar form or from polar to rectangular form. And then you must be able to solve complex equations with two variables. This is similar to your simultaneous equations, where you'll be determining the solutions to two unknowns, and then in this case it is under complex numbers. And then now, when you talk binary numbers, those are not actual number, counting numbers that we are using on daily basis. The binary number is a counting number that is used by your calculators. There's a board inside your calculator, a board inside your computer. That is when we use the binary numbers, mostly used on electronics. And then the word binary is derived from the bi. As you can see, there's a bi in binary there. And then this bi means two. And then why they have selected this word to be a binary word, meaning two. Where does this two now fit in on your binary number? It's because it's a system that represents numbers only in two symbols, that is 0 and 1. So when we talk binary numbers, we will only represent our numbers using a 0 and a 1. That is why they use a bi for two, because there are only two numbers that are representing binary numbers, of which is only a 0 and 2. As you can see, we have an example of a binary number there. It is represented by 1 and 0. These two at the bottom there is a base. So when you write your binary number, you always write it with a base 2. And then now, as I have already elaborated on that one, it is written with the base 2. Okay, use 0 and 1 with the base 2. And then with binary numbers, we have a binary place value table. And then this binary place table, it only works with the powers of 2. That means all your bases will be 2. and then now what we are changing is the exponent there. And then this value table, binary place value table, as you can see, it is having all the bases are 2, 2, 2 there. And then your exponent starts from 0 and then they are increasing. And then these exponents now are presented from right to left. As you can see, it started being 0 and then a 1, 2, 3, 4, 5, 6, 7, and so on. And then now we are representing this using the whole numbers. The exponents are indicated using the whole numbers, starting from 0 from the right hand side throughout to the left hand side. And then now this can be written as decimal numbers. We know that 2 to the power 0 is a 1, 2 to the power 1 is 2, 2 to the power exponent 2 is 4, 2 exponent 3 is 8, 2 exponent 4 is 16, and so on, grade 12. Now let's look at the application of binary numbers. Now let's take the first activity there. We are converting decimal numbers to a binary number. So our first activity states that convert the decimal number 25 to a binary number. So we are going to convert now the normal number that you know of, which is counting number 25. We are now going to write this in a binary form. How do you do that, grade 12? So now I will be having my 25 here. And then I will start dividing by 2. So to change a decimal number to a binary, division by 2 plays a major role there. So if we divide this 25 by 2, we will end up with what? With 12. Remainder 1. Don't bother about remainders. We'll look at that later on, right? And then now 2 into 12, 6 times. 6 divided by 2. If we divide 6 by 2, we'll be having 3. And then 3 divided by 2, it goes once. And then the minute you arrive at 1, you can stop the grade 12. Okay. And then now if we write this in a binary form now, we have divided everything by 2 until we have a 1. Since when you divide 1 by 2, you'll be having a half now. It is no more giving a nice divisible number there. The minute you arrive at 1, you can now identify. The method is saying now, if your number is an even number, then it will take the binary 0. And then if it's an odd number, it will take the binary 1. What do we talk about when we talk even numbers? We talk multiples of 2. That means it's 2, 4, 6, 8, 10, and so forth. Those are the even numbers. The odd numbers are all numbers that are not even. That means we are taking 1. We skip 2, 3, skip 4, 5. We skip a 6, 7, and so forth. Those are odd numbers. So in your solution there, where you are having an even number, it will take the binary 0. And then if it's an odd number, it will take the binary 1. So we are having 25. 25 is an odd number, then it will take a binary 1. 12 is an even number, takes a 0. 6 even, 0. 3 is an odd number, 1. 1 is an odd number, it will take a binary 1. And then now when you write this binary solution, you always start from right to left. So now your solution will go this way. So now we'll say, therefore, 25 decimal number will be equal to 1, 1, 0, 0, 1 base 2. Because we are writing this from right to left on your solution. I hope it is clear, grade 12. That is how we change your decimal to a binary notation. Okay. The next, you can use the calculator method. Remember, I used the manual one on the previous answer by dividing by 2. But with your sharp calculator, you can also use a sharp calculator to find this solution now. So now how do you do that? Now we are still converting decimal 25 to binary, but now with the calculator method. This is how you do it, grade 12. Switch on your calculator, on button, and then your calculator will show this on the screen. That is normal mode of your calculator. And then punch in the 25 on your calculator, then it will be displayed like that as being a 25 on your calculator. And then you go second function button on your calculator, so it must appear on top of your 25 to show that you have now put in the second function. And then now you press in, click on the division button. It is written arrow binary on top there, on your division button there. So you just press your division button, then it will show 25 with an arrow binary there. Okay, automatically it will give you the answer that is 11001. But be careful, it does not show your base 2 there. Okay, but it can give you your final answer exactly as applying the method that you have applied previously. So this will also assist you, grade 12, to find the correct answers there. Right, we are now converting a binary now to a decimal. Remember on the previous activities, we were converting decimal to binary. We are now reversing a binary to a decimal now. And then what is the method around that, grade 12? We have two methods to do that. The first one, we are going to do it manually. And then secondly, we will do it with the calculator method. Now we are having a binary 1 1 1 1 with a 0. For now, we don't indicate the base for now because we want to convert this to decimal now. Remember that place value table that said you start with 2 to the power 0, 2 to the power 1 from right to left. We are now applying that place value table, right? Starting from your right hand side, always we are working from right to left, grade 12. So now the first 0 there will take 2 to the power 0, and then this one 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Okay, and then now we can find the decimal values of this base 2 exponents, 2 to the power 0. Now, grade 12, we are not going to consider the 2 to the power 0 because it is below a 0 there. In order to change to decimal, our decimal will be determined by the values where you have 1, 1, 1, 1, 1, 1. So our solution will start here from 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. So we know that 2 to the power 4 is how much, grade 12? That is our 16 plus 2 to the power 3 is 8 plus 2 to the power 2 is 4 plus 2 to the power 1 is 2. And then we are going to add all of this. That means this is giving us a decimal number that is 30. We can even verify the answer together, grade 12, by taking this 30 now and reversing it back to its binary number. If I'm having a 30, do you still remember the method that we did previously? You say 30, divide by 2, that is 15, divide by 2, that is 7, divide by 2, that is 3, divide by 2 is a 1. And then remember all the even numbers take zeros, and the odd numbers take ones. 15 is odd, 7 is odd, 3 is odd, 1 is odd. And then when you put this in binary notation, is from right to left. Now we are having binary 1, 1, 1, 1, 0. Therefore, you can now put your base. Therefore, this decimal 30 is the same as this binary. Can you see, grade 12 is exactly what was given to us there. So you can be able to test yourself whether you are correct by writing your solution and reversing it back to its binary now. So there's no reason, grade 12, why are we getting that incorrect? Because we have a method of testing that. Okay, you can also use your calculator to find this decimal value for this particular binary. Now you still put your calculator on mode, then it will show the normal mode on the screen, and then second function, it must show a second function on top there to show that you are now on a second function mode. And then now you press the division sign as division button on your calculator. The aim is to go to this arrow binary there, and then it will show 0 arrow binary there. And then now you start putting in your binary number, which is 11110. Then it will show like that on your calculator, still indicating the binary on the bottom there. And then now you go again, second function. Then look at this binary here, there is nothing there. But the minute you put in the second function, it will show second function there. And then from here now you press in the equal sign, and then the aim is to change this to a decimal, because the equal sign is having an arrow with a decimal on top. That is why we are using second function to that. And then now it will give straight your answer of 30 there. So now that is how you can check whether your binary is correct, converted to a decimal using a sharp calculator. Right, we are done now with the conversions of binary to decimal, decimal to binary. We are now looking at the addition of binary number. How do you find the sum to binary? Because binary works only with 1 and 0. Okay, you can't bring in any number there. So now there are rules that we are following. Please take note that if you add a 0 to 0 to binary, your answer will be a 0. If you add binary 1 to 0, your answer will be 1. But if you add a binary 1 and 1, your answer will be 1 and 0, of which with our normal number we say is 10. But this is a 1 and 0 in binary. And then now you will write a 0 and carry 1. You'll see when you do the method of addition on those binary numbers given to us. And then if it happens that you add a 1 and 1, remember 1 and 1 is 1 and 0, right? Of which it is noted as a 10. And then if you add a 0 to that 1, it will still be a 1 and 0 there, of which is noted as a 10, normal 10. But if we are adding now 1 plus 1 plus 1, binary, your answer will be 1, 1. Okay, grade 12, we'll write 1 and carry 1. Let's see now, what do we mean about writing a 0 and carrying a 1? So now here we have to add binary number 1. We are using the grouping method first. We are adding 1, 0, 1, 0, 1. 2, 1, 1, 0, 1. Okay, can you see you are having 4 digits on this one, whereas we are having 5 digits on that one. So that means we'll deal with the 5 digit now. We are now writing, changing the notation now. We have 1 with 5 digits there, that will be 1, 0, 0, 0, 0 for the first one. And then if we come to this digit now, it's a 0 digit, then we will skip that one and come to this one. That will be plus 1, 0, 0. Plus, we skip that one because there's a 0, and then this will be the last one with the plus 1. So we have changed this back to its thousands, tens, and so hundreds and so forth notation. And then now plus, on this side we are having the first one is 1 with 3 zeros. Plus we come to this one, it's 1 with 2 zeros. Plus there's a 0 there, then we consider the last one of being plus 1. So now we have tried to expand this to its thousands, hundreds, and tens, and so forth. And then now we are going to look at something that is matching each other there. Tens to tens, thousands, adding tens, grouping them together. So if you look at the first one, we are having something like 10,000. If you look at the second bracket, we don't have such number, so we leave that one because there's no match for that one. And then followed, we have 1,000 there, then we can bring that one. Still only one term with 1,000, we don't have matching one. But if you look at this 100 and 100, there's a match there, then we will group that together so that we can be able to add them. Lastly, we are having a 1, this one plus that one. Right. And then now grade 12, let's deal with this 2 here and that 2. We are leaving a 10, 0, 0, 0 plus 1, 0, 0, 0 plus. If you add a 0 and 0 there, 0 plus 0 will be 0. 0 plus 0 will be a 0. And the 1 plus 1, do you still remember 1 plus 1? It's 1 and 0. So this will form a 1 and 0, which is like 1,000. Can you see that? And this will now match with that one. And then 1 plus 1 for these 2 here is a 1 and 0, of which is like a 10. And then this is equals to now. We leave the 10,000 there, and then we add these 2. It will be 0 plus 0, which is a 0. 0 plus 0 is a 0. 0 plus 0 is a 0. 1 plus 1 is a 1 and 0. Do you still remember that? And then plus that 10 there. Can you see now we have created a 10 with 3 zeros, which is the same as that one. So we can add these 2 now. It's 0, 0, 0. 0 plus 0, 0. 0 plus 0, 0. 0 plus a 0, 0. And then 1 plus 1 is a 0 there. 1 and 0. So now we are adding the last 10, or 1 and 0, binary number. And then now this will be 0 plus 0, which is a 0. And then 1 plus 0 is a 1. And then we have this value here. We can just bring it here. It's how many zeros? 1, 2, 3, and a 1. So that is the sum of that binary number. This is the first method that we can use of grouping. But there are other methods, grade 12, you check the one that is more easier for you. And then in this case now, let's look at this one. We are using the column addition method now. We are adding the same value. That is 1, 0, 1, 0, 1. And then we are adding this to 1, 1, 0, 1. So we are going to use the column method that you know. It's an addition of the 2. So now we are adding downwards. And then it will be 1 plus 1. We said 1 plus 1 is 1, 0. It's this notation now, grade 12, where we said you write a 0 and carry 1. So if 1, 0, you write a 0 and then you carry 1 to this side. Okay? And then 1 plus 0, 1. 1 plus 0, 1. So we will end up with the 1 there. And then we move on to the next column. It's 1 plus 1. It's a 1, 0, of which is like a 10. You write a 0 and carry 1. So that 1 plus 0 here, it will be a 1. 1 plus 1, it's a 1, 0, of which is 0. You write 0 and carry 1. That will be plus 1 there. So a 1 plus 1, it's a 1 and a 0. We can note that down because we have now finished all the values there. Can you see grade 12? You end up with the same answer as the previous one. You can now bring in your base 2 there. Lastly, you can also use the calculator method to find this sum. It's an on button that will show a normal mode on your sharp calculator. And then you press the second function. Then under your normal mode, there will be second F there indicating that we have brought in the second function. And then you press the division sign or division button on your calculator, your screen will show that you are now on binary. And then you can now bring in your binary sum by putting in your numbers now. It's 10101 plus 1101. Then your calculator will show the sum on the screen, and then you press your equal sign. The aim is to use that decimal button there, and then now this will give us the value 100. Can you see that? It is giving exactly the same answer. So it's up to you, grade 12, which method is more suitable for you. We have unfolded all three. Choose one that is suitable for you. And then now we are moving, we are still on binary. We are now looking at the subtraction of binary numbers. Now, what is important here is the notes, the method on how to do things. That is what you need to know, grade 12. The rules for each application. When you talk to subtraction now, when you subtract a 0 minus a 0 is 0. And then 1 minus a 0 is a 1. 1 minus a 1 is a 0. When you have to subtract 1 from 0, 0 minus 1, you need to borrow. The same method that you are applying when you subtract binary numbers, you are doing that. But when you subtract a 10 minus 1, let's see what is happening now. If it is 10 minus 1, remember at 10, it is actually a 1 plus 1 in binary, right? 1 plus 1 is 1, 0. Do you still remember that? And then that means now we are having a 1 plus 1 minus a 1. It's the same thing as that one. So now if we are subtracting 1 minus 1, that means you'll be left with only 1. So this simply means now if you are having a 10 minus a 1, your answer will be 1. Don't confuse this subtraction and addition with the normal addition of your decimal that you are doing daily. Binary is something else. It has its own rules of addition, subtraction, and so forth. So you ensure that you master those rules, because those are the ones that need to be applied in order to solve the binary numbers. Now, we are subtracting a binary number. Here we are given 1, 1, 1, 1, 1. We have 5 ones there, minus 1, 0, 0, 0, 1 there. So we are going to do this again using the grouping method, and then we will use the column method, and then use the calculator method there. Okay, let's see grade 12 now. Which one will be more easier for you? We are unfolding everything for you, and then you choose the one that is simple for you. So we are subtracting. Let's start by grouping now. We have how many? 1, 2, 3, 4 digits. It will be 1, 2, 3, 4 zeros there, and then followed by this one will take 1, 3 digits. 1, 2, 3 plus, and then we are, remember we started here, and then it is taking 4 zeros. We are now on this one. It's taking 3 zeros. This one will take 2 zeros, and then lastly 1 0, and then with the 1, of which is the last one. Are we having 1, 2, 3, 4, 5? 1, 2, 3, 4, 5, grade 12. Please ensure that you have 5 items there. And then minus, we are now taking the 1, 0, 0, 0, 1. We start with the 1 there. How many zeros? 1, 2, 3, 4. So it will be 1, 1, 2, 3, 4 zeros plus. All right, it's a 0 there. We can't use that one. It's a 0, it's a 0, it's a 0. We only have the last one, which is plus 1. Because if you present zeros, it will be 0, 0, 0, 0, 0. The next one, 0, 0, 0. The next 0. So we are not considering the zeros unless there's a 1 and zeros. Okay? And then now, let's see now. Can you see now? We check what is similar. Can you see that? We have this 1, 4 zeros minus from this bracket now 4 zeros. And then what is another one that is matching? It's a 1 and 1 there. And then that means it will be a 1 from this bracket. And then remember, this one will be a -1 because of that minus, ne? -1. And then grade 12, for these ones, we don't have anything that is mentioned to that one. So we leave it as a 1000 plus 100 plus 10 there. So now this will cancel, that one's a 0, this 1 minus 1, and then we are left with 1000 plus 100 plus 10. That will be 1110 base 2, 1110. Okay, I'm using the 1000 and 10 because that's the language we are used to. But actually here we are working with 111100 and so forth. That is the correct language to use under binary. So we are having binary number 1110 when we subtract the 2. And then let's see now. We want to use the column method now. Still subtracting what? 1, 1. 5 of them. And then we are having 1, 0, 0, 0, 1. And then we are subtracting this using the column method. Remember, we are following the rules from here. It says when you subtract 1 minus 1, the answer is 0. And then 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 0 is 1. 1 minus 1 is a 0. So don't consider that. It's like when you are having 0, 2 is the same as 2. The same applies here. If a coefficient 0 there, we consider the next value there, which is 1110 base 2. So that is the answer for the subtraction of the 2 using the column method. Okay, and then with the calculator method, still we are using the same method. Grade 12, on button, normal mode on your calculator. Second function, you'll see that second function that we have brought in. The second function, as you can see, it was not there initially when you switch on. And then now you press in the division button. So aim is to take your calculator to binary mode now. Our calculator is now on binary as it is showing on the screen there. It must also show at the bottom there. And then now you can bring in your sum that you are subtracting. So you punch in your sum, 1111 minus 10001, and then now equal sign, it will give you the answer, of which is exactly the same answer that you have calculated using the previous methods there. Okay, we now move on to multiplication. Remember, the rules are very important. Now when you multiply a binary, a 0 multiplied by 0 is a 0, a 1 time is a 0, it's a 0, a 1 time is 1, it's a 1. And then the addition plays a major role in all the application grouping. Multiplication still needs the addition of binaries. Your division using long division still needs your subtraction of binaries. Okay, now here we need to multiply 101 by 1111. We have 101 multiplied by 111. And then when we look at 101, we are going to group only one part because now it's easier. You know, mathematical multiplication by 1 is very easy. 1 time is 1 is 1. 1 time is 2 is 2. 1 times 100 is 100. As long as you are multiplying with the 1, it will be the same number. And then now we are going to group only this part here. So that means when we apply grouping here, we'll be having 100 because there are 2 digits there. Plus, we ignore the 0, 1 because it will need us to write 0, 0. And then we consider only the last one, of which is plus 1. And then we are multiplying this with the 111 there. So we are taking the first number there, that is 100, multiplied by 111, plus the 1, multiplied by 111. We are simply multiplying this 111 into each term there. And then this will be 111 multiplied by 100. How much is that one? That will be 111. It's like you're multiplying with a 1 there. And then this will be 111 with zeros there. Okay, let's look at this. Okay, we'll do that when you do column. You'll see what is happening here. And then the last one, plus, we still have 111 multiplied by 1. That will be plus 1, 1, 1. And then if you add these two now, grade 12, we end up with 1. Do you see now? The addition is playing a major role. Addition is playing a major role now. You must still remember those rules. What were you doing when you were adding 1 plus 1, 1 plus 0, and so forth? So we will be adding this one here, plus 0, 1 plus 0, 1 plus 0 is a 1. Okay? 1 plus 0 is a 1. A 1 plus 1 is a 1, 0. So we write 0, we carry 1. Do you still remember that? We carry 1 to that one. It will be 1 plus 1, which is a 1, 0. We write a 0, we carry 1. And the 1 plus 1 is a 1, 0. So because it's the last one, we'll write that 1, 0. And then the base is 2 there. Can you see that addition, grade 12? So this is how you multiply and add your numbers using the grouping method. But I prefer the column method and the calculator method rather than grouping. There is too much confusion under grouping. There are so many numbers that are coming in. But with the column method now, we are still multiplying 1, 0, 1 with 1, 1, 1. Let's see now. This one is a little bit more easier. The rule is saying when you multiply by 1, it will be 1. So we will be multiplying firstly with this one throughout all the values you have there. So it will be 1 multiplied by 1, it's a 1. 1 multiplied by 0, it's a 0. And the 1 multiplied by 1 there, it's a 1. Can you see all is below, exactly below your 3 numbers there? When you multiply this one, your notation will start below that part. So it will be 1 times 1 there, it's a 1. 1 times 0, 0, 1 times 1, it's a 1. Now we are coming to the last one. As we are multiplying with that one, the solution will be below that one. So it's 1 times 1, 1. 1 times 0, 0, 1 times 1, 1. And then we can now start adding them. It's 1, bringing down there. 0 plus 1 is a 1. Can you see addition is now playing a major role again? There we were multiplying, we are now adding. And then 1 plus 0 is a 1. 1 plus 1 is 0, carry 1. And then 1 plus 1, 0, carry 1. 1 plus 1 is a 1, 0. Can you see? We end up with the same answer using the column method. Calculator method, button on, it must be on normal mode before you start doing anything. And then second function, it will now introduce a second function. A division button will now bring in your binary mode. And then now you punch in your multiplication. It's 101 multiplied by 111. Your calculator is already in binary there. Please ensure as you are putting in the numbers there, it is still on binary there. And then now equal sign will give you your answer. So you just write down the answer and then put in your base 2, grade 12. Right, and then now we are looking at the division of binaries. We are done with the multiplication. So when we are doing division of binary, we bring in the long division method, the one that you are using on calculus, differential calculus, when you are using the factor theorem and so forth. I know some are using the synthetic and so forth, but there is a long division method there. Okay, remember with long division, the method says start by dividing. After dividing, you multiply back. After multiplying back, you subtract. After subtracting, you bring down the next term. And then after bringing down the next term, you start from 1 until you finish. That means you divide, you multiply back, you subtract, you bring down the next term until all the terms are now exhausted. Okay, that is the method you will be applying, grade 12. There is no any other method except long division and the calculator method. Okay, now let's start. Do you still remember the notation? This is what you used. And then we have 1, 0, 1, 1, 0. We are dividing that by 1, 0. So now we will be dividing this into the first term there, the first two. terms there. Now it's 1 0 into 1 0, it will go once, and then you multiply back. It's 1 times 1 0 is 1 0. Step number 3, subtract. When you subtract this, it will be 0 minus 0, which is a 0. And then 1 minus 1 is a 0 there. I'm putting the dots there so that I don't become distracted by the zeros, but I know that those are both zeros. And then now from here I can bring down, next step says bring down the next term. I'm going to bring down this number here. Okay, and then now I'm start dividing. After bringing down, you start from number 1. Number 1 says divide, so we are going to divide 1 0 into 1, it doesn't go, it's a 0. And then 0 times 1 0, it's a 0. And then 1 minus 0, it's a 1 minus 0, it's a 1. Okay, and then you bring down the next number now. That will be 1 1. And then 10 into 1 1, it will be 1 times. And then 1 times 10, it will be 10 or 1 0. Sorry. And then now we are busy subtracting grade 12. 1 minus 0, 1. 1 minus 1, it's a 0 there. And then we bring down, start again, bring down the next term, it's a 0. You start dividing 1 0 into 1 0, 1. 1 times 1 0 is 1 0. And then you subtract 0 minus 0 0, 1 minus 1 is a 1. Can you see now we don't have any number to bring down anymore? Therefore, this one will be your solution now. That means division of this will be equal to 10, 1 0 1 1 base 2. Remember the method. No? Remember the method, grade 12. It's the same method that we are using on calculus of long division. Now with the calculator method, ensure your calculator on normal mode. Second function must show them the division button to go to binary, and then now you can bring in your problem. That is 10111 divided by 10. It must show on your calculator with the binary there. If there is no binary, you must know your calculator is not on binary mode. And then now equal sign, then it will give you your solution. That is 1011 base 2 is the answer with the calculator method. Okay, this brings us to the end of the binary numbers, grade 12. Remember, we are also looking at the exponential rules now. We want to move to exponents. Right, we have done the binary. We are talking the first 50 marks of your paper now, grade 12. The first 50 marks, that is question 1, 2, 3, 4 on your exam question papers. And then now we look at the exponents now. Exponents, there are rules that you are following. Remember, also in binary, there are rules that we are following. Those are binary rules. With exponents, again, we are having exponential rules that we are following to answer the exponent. You can't just bring whatever you think of. You must follow the rules in order to simplify the binary, to simplify the exponent, to simplify the sets, to simplify the logarithms. So here we are looking at the rules of exponents. Now we have a product rule. The product rule says that if you are multiplying the same base, you add the exponents. Okay, your answer will be that base with the addition of the exponent. Quotient rule, quotient, remember, is the answer that you get when you divide. That is why we say it's a quotient rule. So when you divide exponent with the same base there, you subtract. So you take one base and subtract the exponent. That is the rule. And then the power of the power rule, it means that you are having a power there and an exponent and another exponent there. That means now you must remember, as long as there is a bracket there, there's a multiplication in between. That simply means now you take the base and multiply the exponents. And then we have the power of the product rule. Product is when you multiply, and then that means this product A times B is sharing the same exponent M there. So the rule says that you can separate this and let A take that exponent and also B take this exponent separately. So Okay, and then now if we have a power of a quotient rule, we say quotient when you are dividing. Okay, then you have that division there, a over b, but this is sharing the same exponent. This says now you can write the top part, numerator, as a to the power m, and the b denominator will also take that exponent m. So this is the correct notation of the power quotient rule. And then we have the zero exponents rule. That means a to the power 0 is equals to 1. That means any number, it can be 1,000. As long as you raise it to the power 0, the answer is 1. You can check with your calculator there, and bear with me, this is 100% correct. And then now we have the negative exponent rule now. A negative exponent rule is when you have a negative on your exponent, like that one. So here we have base a, but with exponent minus m. So now this will create a fraction 1 over, as you can see now, after writing this in fraction form, that exponent is now becoming a positive. For example, if I'm having 2 to the power minus 2 there, this will be 1 over 2 to the power 2. My exponent is now becoming positive, and then we end up with 1 over 4 there. That is what we mean about this rule. And then now it helps you to get rid of negative on your exponents or on your answers. Maybe the examiner say no negative indices on your answers, so you must get rid of the negatives on your exponent, like applying this negative exponent rule. And then there's a fraction exponent rule. Fraction is when you have now rational exponents. You have a fraction on your exponent. So you can write this in sets form, or you can reverse the set to exponential type. For an example, let's say I'm having the cube root of x to the power 2. This can be written as x to the power 2 over 3. Can you see that? If I'm taking this back to its set, that means this 3 will go to the set there, and then I will be left with my x squared. So that is what this rule means. Reversing your rational exponent to writing your rational exponent in set format, or writing your sets in exponential form. Right, now we have an activity here, grade 12. We are having an exponential expressions now. These are not equations, but they are expressions. They say simplify without using a calculator. So the method that we'll be applying here, we will be using those exponential rules in order to simplify our expressions. And then now when we are dealing with the exponential rules, we are relying mostly on the basis of the prime numbers. So we are using prime basis in order to simplify our expressions or our exponential equations. Now, what do we mean by the prime basis? We are taking it from the set of prime numbers. Our prime numbers, remember, do you still remember them, grade 12? They start from 2, and then followed by 3, and then followed by 5, and then we take a 7, and then after 7, 8 is not a prime number, 9 is not a prime number, 10 is not a prime number, we go 11, and then we take 13, 12 is not a prime number, and then and so forth, continue like that. So these are the numbers that we are using as our basis in order to make our life easier in exponent. Okay, in collaboration, remember we will be using this together with our exponential rules. Now we have this expression here. They say simplify this without using a calculator, grade 12. Without using a calculator, as you can see, it is highlighted there. You can't just take your calculator and put in the values. No, you need to apply your rules in order to simplify this. So now you look at your base now. I'm having 9, then I'm having 27, I'm having 81. And then we said we must use the prime basis. So now which base can we use now for 9, 27, and 81? 3 is the most suitable one because we can write 9 as 3 to the power 2. multiply, we can write 27 as 3 to the power 3. And then we keep the exponent that was there initially. And then 81, we can write it as 3 to the power 4. And then we have the initial exponent there. And then from here now, remember there's a rule, a power to power. It says that you multiply the exponent. Because of that bracket, you are going to apply that rule now. Can you see now? We are applying the rules to solve this. So we will be distributing these 2 to both your exponent there. That will be 3 to the power 2n minus 2. We are done with the first one. We move to the next base. We are distributing 3 to each term there. That will be 3 to the power 3 times 3. That is a 9. And then 3 to the power, 3 times minus 2 is minus 6n. On the denominator, we are distributing a 4 to 2 and the minus n. That will be base 3. 4 times 2 is 8 minus 4n. Okay, continue. Right, there's a rule that says when you are multiplying the same base, you add exponent. When you divide, you subtract exponents. Therefore, you'll be applying that rule because here we are multiplying and dividing. Can you see whatever simplification we are doing, we are applying exponential rules. Right. Then we have the base. Now we are going to present the base only once because our bases are the same now. So now we are representing base 3 for all of them. And then it says when you are multiplying the same base, you add exponents. So you'll be having 2n minus 2 plus 9 minus 6n. You add them. And then this one, we subtract them now because we are dividing. Okay? 8 will be minus 8, minus 4 will be a plus 4n because we are subtracting. And then let's simplify. We are having our base here. So now we look at the like terms on the exponents now. So we have 2n minus 6n, that is minus 4n. Minus 4n plus 4n, it gives us a 0. That means all the n's are cancelled. Now we consider the numbers. Now we have minus 2 plus 9, that is plus 7. Plus 7 minus 8, that is a minus 1. Then this will be 3 to the power minus 1. Remember now, get rid of the negatives on your indices or on your exponents. Therefore, this will become a fraction 1 over a 3 to the power 1, which is still a 3. Great job. That is how we simplify this. And then it is allocated 4 marks. It will be 1 for writing this with base 3, all of them. And then 2 for simplification of adding and subtraction, applying the rules. And then the third mark will be for simplification to 3 to the power minus 1. And then lastly for writing that without the negative indices. So that is the application or the allocation of marks to that particular problem. Right. We have done the expression. We want to look at the equation. Now we are still on exponents and then we need to look at the equation. But with the equation now, there is a rule that we are applying. This rule states that when bases are the same, we apply this rule now. So now you have an equation. How do we know it's an equation? There's an equal sign there. On expressions, there are no equal sign. You continue as you are equalizing and simplifying. But this will be given initially something equal to this. So we know that we are busy with an equation. So this rule states that you must have what? Same bases on both sides. There must be one base, but they must be exactly the same. And then now, if that is the case now, it states that you can equalize the exponents. For an example, if I'm having 2 to the power x equal to 2 to the power 2, this rule states that if I'm having the same base both sides, I can say therefore x is equal to 2 is my answer. I can equalize the exponents. Okay. And then in case where bases are not the same now, like our condition here, we have base B, we have base A. And then this A, remember, is to the power y, but it's fine. we don't have same basis. It is where now you are bringing in your logs. That means you'll be putting a log this side. For an example, let's see now we have in b to the power x. This is what happened. And then you put a log on this one. So this b will come as being the base to that log. So the minute we drag this b to that side, and then x will go down there. So we end up with this x equal to log a base b. That is how it was done. And then let's take for an example, if we have now a number 3 to the power x is equals to 9. And then we want to solve for x then. Okay, this one, let me make it 2. And then we have equals to 2 there. We'll bring a log to this side, log 2. The side without an x, right? And then we bring this 3 down there. Then the minute we do that, x will go down and be a base. So that is what we mean about applying that rule. So it's called applying logs to both sides of your expression, of your equation. Okay. Now we are looking at the activity now, grade 12s, on solving for x on exponential equations. Okay. Remember now our WhatsApp number is 079-454-9535. I am repeating it. It's 079-454-9535. Grade 12, you are more than welcome to send your clarity seeking question to that particular number, or any alternative solution or any short method that you can share with us, you can share to that particular number. Okay, back to our activity. It says solve for x when you are given that equation there. How do we know it's an equation? There's an equal sign between your terms. Right. Now we look at the equation now. We have something in common there. Can you see that? 3 to the power x and 3 to the power x now. The minute you have highlighted or identified that common term, we are going to deal with this one and separate the exponents there. And then you have that 2 multiplied by 3 to the power x plus 3 to the power x. We are now separating this back to the separated bases there. And then this is equal to 63. Now we can target what we said. It is common in the two terms on the left hand side. So we will take out as a common 3 to the power x. And then the minute we take out the common factor here, we will be left with a 2. Plus we take out a common factor here, we'll be left with 3 to the power minus 1, of which is 1 over 3, equal to 63. And then now we have 3 to the power x into 2 plus 1/3, that is 7 over 2, 7 over 3, sorry, equals to 63. Then we are going to divide both sides by this 7 over 3, divide by 7 over 3, and also this 63 will divide it by 7 over 3, so that this 7 over 3 can cancel that one. Then we'll be left with only 3 to the power x. And then this 3 to the power, the 63 divided by 7 over 3 will give us a 27 on the right hand side. And then now we have 3 to the power x. Remember, there is that rule which says if you have the same base on left and right, you can equalize the exponent. So now 27, we are going to write it with its prime base. That will be 3 to the power of 3, the same as 27. So we have the same base, grade 12. We are not dividing by 3, but we have the same base, therefore we equalize the exponent. The rule allows us to say x is equals to 3 is our solution there. Okay, that is how we simplify this exponential equation. And then now we move on to sets. With the sets, we also have rules. Everything we are doing today, it talks to the rules, right? And then we are having the rules for sets. And then the set states that if you are multiplying same sets, can you see now is the nth root of x with the nth root of y. You can multiply this and have a product in a single nth root now. You can put them in the same goods. For example, let's say we are having the cube root of 2 multiplied by the cube root of 4. This rule states that you can only have the one cube root that is representing both, and then you can multiply what is in there. And then we are looking at the cube root of 8. Okay, that is what it means. Okay, and then this one now we are having the square root, and then inside that we are having fraction x over y. This simply means now if this quotient x over y is sharing the same square root side, you can separate the square root and take x must take the square root side, and the y will also take the square root side, keeping their position of division there. Numerator being numerator, denominator being a denominator then. And then rule number 3, we have talked to this when we are talking to exponential rules, that you can change your sets into exponential notation. That is exactly that. I've already elaborated on that one. And then this one here, it states that if you are having the nth root of x and then with closed bracket there with exponent n, you can bring this exponent in. For example, let's say I'm having the cube root of 8 and then to the power 2. This rule says I can write the cube root of 8 squared inside the root sign. I can bring this square root to that base 8 there. Okay, those are the sets rules. Now let's simplify the sets expressions. Simplify without using a calculator, grade 12. Without using a calculator. Your calculator might assist you to ensure that you are going correct, because now our calculators can give us the simplified set form. So, but you need to simplify this without using a calculator. How are we going to go about this one? You need to identify two numbers. When you multiply, they give you 8. But one of those numbers must have a square root. Okay, that means now this square root 8 will write it as square root of 4 times 2. Why? This 4 is having a square root. And then now moving into the bracket, 242, we are going to write it as the square root of one number with a square root sign, 121 times 2, which is 242. We are not changing the values, but we are just changing the notation. And then 72, now we are having 36, of which is having the square root multiplied by 2. We are still having that bracket there. So we will end up with because the square root of 4 does exist. Square root of 4 is 2. So we are going to take out the square root of 4, which is 2, and then we'll be left with square root of 2 inside. So when you put square root of 8 in your calculator, it will take you straight to 2 square root of 2. So your calculator will assist you to ensure that you have written the correct answer there. Okay? And the square root of 121 is 11. That means we'll take out that square root and be left with square root 2. Minus the square root of 36, which is a 6, and then we'll be left with square root of 2 there. Okay, we can now simplify inside the bracket. We are having 11 square roots of 2 minus 6 square root of 2. It's like having 11 apples subtracting 6, okay? So that means it's 11 minus 6, which is 5. Then it will be 5 square root of 2. Right, and then we can now multiply. It will be 2 times 5, which is a 10. And the square root of 2 multiplied by square root of 2, it is square root of 2 squared. Then the 2 will cancel the root signs, like 10 multiplied by 2, of which it's a 20. So that is our answer. So when you put everything into your calculator, that you punch in a calculator and say square root 8, bracket square root of 242, minus the square root of 72, close bracket. Your calculator will give you a 20. Straight to the answer. So answer only are not acceptable, grade 12, because we said to you without using a calculator. So these 3 marks will be 1 mark for writing this in simple set form. The second mark will be for simplifying this up to 10 into square root 2 maybe, or at this level here. And then the last mark will be for your answer, grade 12. So answer only will not be allocated marks, because it will be clear that you have used a calculator. That is how you simplify set expressions. And then with laws of logs now, we are working with laws and rules, grade 12 today. You follow the rules. If you don't follow the rules, you will never come all right. And then we have laws of logarithms now. With the laws of logarithm, the first rule says that if I'm having a log and I am multiplying the log of m times n, I can separate and have 2 logs. That is log m plus. If I am multiplying, it will be a plus. Can you see that relationship, Nyana? That relate to exponent. Remember, multiplying the same base of exponent, you add exponent. The same applies here. You multiply your logs, you can separate and have the addition of your logs. Now it's log of m plus the log of n there. Okay, rule number 2, it says when you are dividing, you will subtract. So it will be log m base b minus the log n base b there. This b here, we call it a base, right? And then now rule number 3, we are having log m to the power k, and then that is with base b there. So this rule says that you can take this exponents here and put it in front of your log there. Then you'll end up with k log m base b. So this simply means now, grade 12, if I'm having the log of 2 base 2 and then to the power 3 here, I can write this as 3 log 2 base 2. Okay, that is what this means. You can take that exponent to the front there. That is the correct notation of that log. And then if I'm having the log of 1, it can be log 1 base 100, log 1 base 20, log 1. As long as it's a log of 1, the answer will be a 0. You can test with your calculator there. And then the log of, if your log is the same as the base there, log of b base b is equals to 1. For an example here, in this case here, if we have the log of 2 base 2, this will give us a 1. So we'll end up with 3 times 1, which is a 3 there. Can you see this is creating a 1? Why? Because a log is the same as its base. And then lastly, we are having the log of b to the power k base b will give us a k. Where does it come from, this one? Remember now, if you are having an exponent, if I'm having the log of b to the power k, and then I'm having base, I can take this k to the front there. This will be k, and then I'll be left with log b base b. Remember, log of the same base, and then this will give us a 1. Then it will be k times 1, which is a k. That is why we are saying this will be just a k. It comes from that simplification. All right. Now, let's see how do we simplify the log expressions. Activity 9.1, simplify without using a calculator again, grade 12. That means you need to apply those logarithms, rules or laws in order to be able to simplify this. Number 1, if we look at the bases here, they are not the same. We have base 32, and then we have base, if there is no base, the base is 10. They don't normally write it, okay? And then now the minute we have different bases, that means we need to apply the change of base method so that we can deal with same bases. How do we do change of base now? Change of base, we'll write this log 8 base 32 as the log of 8 over the log of 32. Can you see now our bases are now 10, 10? If there is no base, remember the base is 10. And then this will be plus log 10. We know that there's a 10 there, there's a 10, there's a 10 there. We are now having same basis. And then now this log 8, we'll write it in exponential form. It will be log of, we are still using those prime bases. That will be 2 to the power 3. Correct? And then log of 32 is log 2 to the power of 5. Plus log 10 plus log 10 is a 1. Remember, a log with the same base is equals to 1. And then here we apply that rule that says you can take this exponent to be a coefficient there. So we'll end up with 3 log 2 over, on the denominator is 5 log 2. Same application, same rule applied there. And then here plus 1. This log 2 will cancel log 2. Can you see that, grade 12? And then we will be left with 3 over 5 plus a 1. And then 3 over 5 plus a 1 is 8 over 5. That is your answer. And then this is allocated 4 marks. 1 mark will be for indicating that log 10 base 10 is equals to 1. The second mark will be for writing this in the simplest form of 3 log 2. And then the third mark for writing 5 log 2. And then the last mark will be for the addition there. So that is your 4 marks allocation, grade 12. And next activity, in this one, remember that one was a log expression. This one is a log equation now. How do we know it's an equation? There's an equal sign there. And then with the log equations, we are still applying the rules. Remember, the rule says that if you are subtracting, you will divide your log. So we'll write this as a single log. It will be the log of what now? Put a bracket, x plus 2. Because we are subtracting, it will be divided by x here. And then still equals to 1 on the right hand side. And remember, if there is no base here, our base is actually 10. And then we are going to apply that rule. Remember, I indicated to you how to reverse a log, an exponential equation to a log and so forth. That is the application we'll be applying here. And then now if we reverse this to its exponential form, we'll be having this x plus 2 over x on the left hand side. Then this 10 will go back to this side. And as it joins that side, this will kick up the exponent 1. It will be 10 to the power 1 on the right hand side. So now we are having x plus 2 over x equals to 10 to the power 1. 10 to the power 1 is the same as 10. And then now we can now cross multiply. This will be x plus 2, x plus 2 is equal to cross this x to 10, that will be 10x. And then now the 2 is equal to 10x. We are now transposing this x to this side, it will be minus x. And then we end up with 2. 10 minus x is 9x. Then we divide both sides by 9. So our x will be equal to 2 over 9 because a 9 will cancel a 9 there. So that is the solution of x, grade 12. Allocation of marks will be for applying the rule that subtraction will end up being a division. That is the first one. Mark number 2 is for applying the changing of logs to its exponential notation. And then the third mark will be for simplifying by cross multiplying that. And then the last mark will be for the answer there. So that is your 4 marks allocation, grade 12. And then now we move on to quadratic equations. Remember, we are talking to your first 50 marks on your question paper. A quadratic equation in x is an equation that can be written in a standard form. If it is in terms of x, it will be ax squared plus bx plus c equal to 0, where a, b, and c are real numbers. Okay, this a and b, c there, they must be real numbers. And then a must not be equal to 0, because what happens now if a is a 0, grade 12? Let's see what happens now. This will be 0. So our equation will now be bx plus c equal to 0. Can you see now this is now a linear equation? It is no more a quadratic equation. Hence this restriction. If it's a quadratic equation, a cannot be a 0. So now, there we have to solve the first quadratic equation. They say solve for x in this particular equation. I'm giving you 2 minutes, grade 12, to work out this solution and see how far can we go and address the misconceptions that might come in as you are solving this. Your 2 minutes starts now. Okay, grade 12, let's see how far did you go with this one. Remember our WhatsApp number is 079 454 9535, where you can send in your clarity seeking questions or any alternative method that you need to share with us, or any easy steps to answer any of the problems that we are solving today. Okay, now let's look at our activity there. We were solving for x, and then we are given half x into 2x minus 1 equals to 0. The minute you are given brackets on the left hand side and they have equated them to 0, that simply means, grade 12, they have already factorized for you. Okay, so you can just say half x is equal to 0, or the 2x minus 1 is equals to 0. So now divide by half, x will be equals to 0 for that one, or 2x will be equal to 1 divided by 2x will be equals to half there. So your mark will be for x equal to 0 and for x equals to half. They have already factorized for you. But we know that most of the time we are relying on the quadratic formula for our factorization if we have a challenge with the factorization on quadratic equations. And then now, when you are going quadratic formula, remember all your equations must be in the form ax squared plus bx plus c equal to 0. Because now when you talk to quadratic formula, we are talking the formula minus b plus minus the square root of b squared minus 4ac over 2a. I know there are learners who are relying on this formula 100% for the factorization. So grade 12, if that is the case, this will also work for you. You take that equation that is given to you, and then you multiply out the brackets now. That is the half of 2, which is 1, and then x times x will be x squared. And then the half of minus 1 will be minus half x equal to 0. And then if you look at the value of a here, it will be 1. The value of b will be minus half. And then the value of c, it will be 0. Hence, there is no value there. And then you can now use your quadratic formula and substitute. Our b is minus half plus minus the square root of minus half squared minus 4. A is equals to 1. And the c is a 0 there. And then all over 2 into a, which is 1. And then negative times negative half will be positive half, plus minus negative 1 over 2 squared, it will be 1 over 4. This one, negative 4 times 1 is negative 4 times 0, it's a 0 there. So inside the square root sign will be left with a quarter, 1 over 4. And then 2 times 1 is 2. Or you can just put this into your calculator, it will give the straight answers, right? And then now this will be half plus minus the square root of 1 over 4 is 1 over 2 over 2. So we are having half plus half over 2, or the half minus half over 2. So half plus half is 1, therefore for this one we are having 1 over 2. Or half minus half is a 0, 0 over 2 is a 0. Can you see grade 12? You'll end up with the same answers, but it is taking more time than noticing that they have already factorized for you there. But anyway, you'll end up with the correct answer there. So now quadratic formula is what you applied above to find factors. If you are not comfortable with finding factors, you can use the quadratic formula. So this formula was derived from the quadratic equation. As you can see, it's having the a, b, and c's there. Okay, so this one is a quadratic equation, this one is a quadratic formula, and a must not be equal to a 0, because if a becomes a 0, this is no more a quadratic formula. If a becomes a 0, this will be undefined. The quadratic formula will be undefined because division by 0 is not allowed. Okay. Now, let's look at the application of the quadratic formula now. They say solve for x, and then you are given minus x into 6 minus x equals to 4. And then there's a message next to your question that says round off to 2 decimal places. The minute you see this message, you must know that this equation does not have factors. You are forced to use the quadratic formula. And then grade 12, there are misconceptions now. Learners will be thinking that if they have minus x and 6 minus 4 brackets on the right, 6 minus x equal to 4, they will think this is already factorized for them. No, it is only factorized if there's a 0 on your right hand side. You cannot say minus x is equal to 4 or the 6 minus x is equals to 4. That is totally wrong. Okay, we only do that if the value on the right hand side is a 0. I hope we are clear on that one. So in this case now, it's a must. You must multiply out your bracket. So this will give us a minus x times 6 is minus 6x. Minus x times minus x is a positive x squared. And then we transpose 4 to the side, it will be a minus 4 equal to 0. But if you look at this, this is not in a standard form. To be in a standard form, it must be ax squared plus bx plus c equal to 0. That will be a standard quadratic equation. So we are going to rearrange this in order. Then we start with the x squared is 1x squared minus 6x and minus 4 equal to 0. Therefore, this is now in a correct standard. Then the value of a is equal to 1, the B value is minus 6, and the C value is minus 4. Please take the value with the sign to be 100% correct. Then we apply the quadratic formula now, which is minus B plus minus the square root of B squared minus 4AC all over 2A. We are now substituting the value. Remember, the formula is having a negative for the formula, and the B value is also bringing another negative. Be careful of that, grade 12. There must be 2 negatives there. And then we have a plus minus the square root of B value is minus 6 squared. We are now substituting into the formula. The A value is 1, the C value is minus 4. Be careful of that negative on C again. Most of the time you omit it. And then now the A value is equal to 1 there. And then after substituting there, you can simplify this into your calculator. It will give you a simple set form. That will be 3 plus minus the square root of 13. And then you press in your SD button to change this into decimal notation. This will give us 6,61 rounded off correctly, or X will be equal to a minus 0,61. Okay, grade 12, with this one, before we allocate marks, we will check whether have you followed the instruction that is saying round off to 2 decimal place. Round off to 2 decimal place means that you take 2 numbers after a comma. And then if the third number is 5 upwards, you must add 1 to the previous one. If not, you leave it as it is, but it must be 2 decimal, right? So the first mark will be for simplifying this into the standard form, correctly noted there, removing the bracket. The second mark will be for substitution into the correct formula. The third mark will be for the first X value correctly rounded off. The fourth mark will be for the second X value correctly rounded off. That is your 4 marks. And then we have what we call quadratic inequalities. What is the difference between a quadratic equation and a quadratic inequality? With inequalities, we are using greater than, less than, or greater and equal to sign, or the less and equal to. Whereas with an equation, we are using only an equal sign. Okay? How do you know it's an inequality? It must have a greater than, a less than, a greater or equal to, or a less or equal to symbol. Then this is an equality. You cannot solve it as if you are solving an equation. There is a method of solving this one. Now, the symbols that we are using now, if we are having an inequality sign, either being greater than or less than, as you can see, these ones are not having an equal sign below. Therefore, you use an open dot on the number line for both critical values. I'm going to show you when we are doing an activity on this. And then also the notation for this is round brackets when you are noting your solution, because there is no equal sign. But if you are having inequalities, it is still greater than, but is greater and equal because it's having an equal sign. Or less and equal because it's having an equal sign. You use a shaded dot because your solutions are now included. They are part of the solution. Whereas with the open dot, the open means the solutions are not included. So now we shade the dots to show that the solutions are included. And then we use the square bracket to show that they are also inclusive. Okay, so that is the difference between the two. No equal sign, open dot, round bracket. With equal sign, it's a closed dot with the square bracket notation. So that is the notation on inequalities quadratic. Now we are giving quadratic inequality to solve here. They say solve for x. Question will be asking for the same thing as in equation, solve for x. Yours is to check whether is it an equation or is it an inequality now. And then when you check this one, you can see it's an inequality. And this inequality does not have a square, an equal sign. Therefore, is that one of an open dot or the round bracket notation? Okay. But before now, we can attempt to answer any of this grade 12. As you can see, we are having brackets on the left hand side and the 0 on the right hand side. That simply means what, grade 12? They have already factorized for you because there's a 0 on the right hand side, correct? So there's no need to multiply out those brackets. They have already factorized for you. That's the first thing. Secondly, you check now, do you have any negative on your x after factorizing? Yes, you have a challenge here because this x is negative. You need to get rid of that negative because now it's going to affect your inequality sign. So now if you take out the negative here from this bracket, you'll be left with the x that is positive and the 2 will be now negative. The second bracket is not affected because we wanted to change that minus x to be a positive x. Now we have a negative in our expression on the left hand side. We are going to multiply by that negative or divide by negative both sides. The minute you divide or multiply by negative, then you'll be left with x minus 2. We have removed the negative now. It will affect your inequality sign. Multiplication by negative or division by negative is affecting the inequality sign. This inequality sign, it was initially greater than, it will now be a less than 0 inequality. So now our solution will be based on the less than inequality sign, all right? And then now remember, after factorizing, after having factors, you look for the critical values. And then our critical values, first bracket will give us x equal to 2 or x equal to minus 5. Why are we saying these are critical values? These are not yet our solutions, grade 12, because we are working with an inequality, not an equation. The minute we say equal to 2, we are now changing this to an equation. That is why we are criticizing those values and saying these are the critical values, not yet the solution, because we are using equal to 2 and the equal to minus 5. After critical values, now we can put in the critical values on our number line, starting with the smaller number. Minus 5 is smaller than 2, followed by the bigger one. And then now when you look at the inequality sign, it doesn't have an equal sign. Inequality sign without equal sign. Therefore, we use an open dot. On the critical values, we put an open dot. That means minus 5 and 2, they are not part of our solution. Hence, we are using open dots. Now, we look at the inequality sign now. If the inequality sign is less than, we are shading in. For inequality sign less than or less and equal to, our shading will be in between, because we are less and equal there. But if this is greater or greater and equal, for greater than, we will be shading, we'll be having our values that we shade out. So it's like somebody gaining weight, you shade out, okay? And then if that is the case, the solution will be having two solutions with an or in between. The same applies here. It will be shaded dot, but you will be having two separate solutions. That is the shading part that is determining your final solution. So let's go back to our problem now. Avoid using those. You avoid the inequality after multiplying with the negative sign. Therefore, we are concentrating on the less than inequality. So if it is less, you are reducing it, okay? Less than, therefore it will be shaded in between. So now if it's a combined solution, that means your x will be in between. Between what? Minus 5 and a 2. Because the solution is what? Is in between grade 12. Okay, let's say now our solution was greater than. Let's say this was x minus 2 into x plus 5 with greater and equal to 0 now. So we will be still having the same critical values, minus 5 and 2, but with a closed dot now. And then since it is greater than, we will be shading out. So greater than we shade out, then it will be shaded out like that. So there's an or in between there. So now the first x value is taking that direction of which is less. Can you see that? It must correspond with your arrow of the inequality sign, must correspond with your arrow there. That will be minus 5. And then this one will be x greater than. Can you see? Greater than goes that direction. And then 2. But because it is having an equal sign, we must also include the minus 5 and the e2. We put an equal sign there. Okay. So these are the notation. There is another notation. We talked of round bracket and the square bracket somewhere. But preferably grade 12, this is the best one because we avoid mistake. Let's look at the first solution. I'm talking to that one. If we are using the notation of bracket, this will be x is an element of no equal sign. Therefore, it's a round bracket starting with the smaller number followed by the bigger number. That is the bracket notation. With this one, it will be saying x, it's an element of, it's not an easy one because when we say this arrow goes to the left, it goes to the negative infinity. So now infinity is not included. It will be a round bracket starting from negative infinity up to negative 5. But negative 5 is included because it's having an equal sign. Or x for the 2 part, for the solution for 2 is an element. Remember, this is going to the positive infinity. It will start from 2 with a square bracket up to the positive infinity. Infinity is taking a round bracket. Can you see grade 12? There is a lot to take note of when we are using the bracket notation. All right. So now I think the first one is the easiest one. So we have what we call the simultaneous equations. We are still on equations. With the simultaneous equations, it's where we are having two unknowns, solving for two unknowns. That is why we say simultaneous. Simultaneously means at the same time. So we will be solving two unknowns at the same time. Since it is simultaneous equations, solving two unknowns, we also need two equations in order to solve simultaneous equations. Let's see now. We have the first equation happy, and then we have the second one. And then with your grade 12 syllabus, it must always be a linear versus the quadratic one. A linear equation versus the quadratic one. So now the first question here says express y plus x minus 10, which is your linear equation, equal to 0, in the form y equal to mx plus c. Okay, now they want us to make y the subject of the formula in this particular equation. So we will leave y on the left and then transpose the x and the 10. Then x will become minus x, and then minus 10 will become positive 10 because we are moving that now to the right hand side. So that is all for 13.1. And then now the next question, point 2, it says hence or otherwise solve for x and y. So now what we have actually done here, we were given equation 1 and equation 2 there. We have now created our equation 3 there. And then we are going to substitute now. The method says substitute equation 3 into the equation that you didn't use. That will be equation 2. So you take your linear, you substitute it in the quadratic equation. Our quadratic says x squared minus xy plus y squared is equal to 28. So wherever we are having a y, we are going to substitute that with minus x plus 10. We have y there, we have y there. There will be a substitution for y. Okay, so we leave x squared, no substitution for x, minus x for y. We are now going to substitute minus x plus 10 plus for y, we are substituting minus x plus 10. But be careful, grade 12, this y is having an exponent too. And then we bring in the minus 28 to the left, equal to 0 then. And then after substituting the third equation, can you see now you only have x as being unknown, whereas initially you were having x and y in that expression. So the purpose of substituting is to get rid of one variable so that you can solve the one that is left. So now we are having x squared, we leave that one, we are going to deal with the brackets now. So it's minus x times minus x is a positive x squared. Minus x times 10 is minus 10x there. Done with that one, then we move to the another bracket there. Remember here we are actually multiplying two brackets of minus x plus 10. It's like it's minus x plus 10 into another bracket of minus x plus 10. So you multiply them out and bring your answer and write it here. And then there's a short method of doing that. You can square the first term. Minus x times minus x is x squared, positive x squared. Minus x times 10 minus 10x times 2 minus 20x. And then square the last term. 10 times 10 is 100. So that is another way of removing your brackets with the short method. You can calculate them there. They will give you exactly what I have there. Okay. And then now the next step, we will be looking at the like terms now, grade 12. We are checking the like terms. That will be x plus x, which is 2x squared. The x squared plus x squared, 2x squared, plus another x squared, that is 3x squared. Minus 10x minus 20x, that is minus 30x. And the 100 minus the 28 there is giving us the plus 72 equals to 0. You can work with this equation to your quadratic formula, it's fine. Or you can simplify for those who are comfortable with using the factorizing with the short method. They can divide by 3 to make their expression more easier, their equation more easier. Divide by 3, first term you'll be left with x squared, 1x squared, minus 30 divided by 3, minus 10x. 72 divided by 3, that is plus 24, equals to a 0. And then we are looking for factors of 24. When you add them, they give you a 10. That will be 6 times 4. You can't just take any factors. I know that 12 times 2 is still 24. But you can't use that because you need to listen to your trinomial. It's saying factors of 24. When you add them, they must give you minus 10. That means it is minus 6 and minus 4. Because negative times a negative is a positive. And when you add them, they give you minus 10. When you multiply them, they give you positive 24. Therefore, these are the correct factors. Then x will be equal to 6 or x equals to 4. These are the x values, grade 12. But remember, we are solving for x and y simultaneously. Up to this far, we have just solved for x. We need to solve for y. The easiest way is to take that equation 3 and substitute the x values on that one. So this one, the y value, the first one will be minus. We are using the third equation, minus x plus 10. We are now substituting the first x value 6. That will be minus 6 plus 10, of which it will be a 4. And then secondly, we now substitute a 4. That will be minus 4 plus 10. That will be a 6. So when you write this in coordinate form, you can see that if your x is 6, your y will be 4. Or if your x is 4, your y will be 6. So that is the expected solution for this simultaneous. And then now let's allocate the 6 marks now. 1 mark will be for substituting the third equation into the correct quadratic equation. The second mark for simplifying this and end up with the quadratic equation. The third mark is for the factors. Okay. The fourth mark will be for the x values, both of them. and the fifth mark will be for the first y value and the last one for the second y value. Hence, this worth 6 marks. Okay, and then we are still continuing. We are still on equations, grade 12. There is a lot, grade 12, on equations. We now look at the literal equations. We are still busy with your 50 marks of your paper 1, of which is the first questions on your question papers. And then this one is, it falls under manipulate formula. We sometimes call it the literal equations. With the literal equations, we will be working mostly with the variables on our equations. And then most of the questions on these questions, they are related to your trades, electronics, electrical, mechanical, technology, and so forth. And then now in this case, we are given the formula used to determine the pressure of the fluid in a hydraulic system, as shown in the diagram, is given by this formula. P is equal to F over A, of which P presents the pressure of the fluid in pascals, and then F is the force in newtons, and the A is the area in square meters. And then now the first question here, we need to make A the subject of the formula. That is very easy, grade 12. We will be cross multiplying this. Okay, we cross A to P there. That will be AP equals to F. Because we need an A, we will divide by P both sides. Therefore, A will be equal to F over P there. Done. 1 mark. And then now the second one, hence or otherwise, calculate the value of A. If P is given as being that value there, and then F is given as that one, express the value in scientific notation. After calculating, you must express your answer in scientific notation. Okay, grade 12, you have already identified that A is equal to F over P. What is F? 25 times 10 to the power 3 newtons over the P. P is 25,984,480,5 pascals. And then when you divide these two now in scientific notation, they give you 9,6 times 10 to the power minus 4, of which will be in square meters, since the area here is given in square meters. So these 3 marks now will be for the substitution of P, substitution of F and P, and then for your answer in scientific notation. Right, we are done with the equations. We are now moving to the nature of roots. The nature of roots, they have a relationship with quadratic formula. So we are applying the nature of roots on quadratic equations. That means they have the relationship with the discriminant in quadratic equation. What is the discriminant? Discriminant is b squared minus 4ac. When we talk discriminant, we say this is equal to b squared minus 4ac. But where do we get this b squared? It is from your quadratic formula. Quadratic formula. Inside your quadratic formula, there we are having that discriminant. Hence, we say now this is the discriminant in your quadratic formula. So it's having a relationship with quadratic equations and your quadratic formula. So now when we calculate this, we still use the B form quadratic equation, the A value and the C value form quadratic equations. So now if you calculate a discriminant and find that your answer is less than 0 meaning your answer is negative, your solution, therefore your roots will be non-real, or those are the imaginary roots. Your graph will never touch the x-axis. And then now if you calculate the discriminant and then your answer is 0, therefore your roots are real, rational, and equal. Real, rational, equal, RRE, okay? And then if you find that your discriminant is greater and equal to 0, it's a positive number that is greater and equal to 0, not or also equal to starting from 0 to positive numbers. So now that case satisfies for these two conditions. And then how do you differentiate them? If your number is a perfect square, when you talk perfect square, we are talking perfect numbers. The numbers that are having the square root. Square root of 1 is 1. Therefore, 1 is a perfect square. The square root of 4 is 2. So 4 is a perfect square. The square root of 9 is 3. Therefore, 9 is a perfect square. So if you calculate the discriminant, find that your answer is positive and it's a perfect square. Therefore, the roots will be real, rational, but unequal. That is the difference between these ones are equal, these ones will be unequal. When the number is not a perfect square, this is now changing to irrational. Remember, it was rational there, this will be irrational. It will still be real, but irrational, and then still be unequal for those conditions. That is how you determine the nature of roots. Now we are given this equation here. They say determine for which values of k will q have equal roots. Okay, equal roots. Do you still remember when do you have equal roots? It's when your discriminant is equal to 0. That is the only condition that is giving us equal roots. In this case, what is our discriminant? We have identified earlier on that discriminant is what is inside the square root of the quadratic formula. So in this case, it will be 1 minus 3k, of which is equal to k. Minus 3k, transpose 1, minus 1. Divide by minus 3 both sides. K will be equal to minus 1 over minus 3, of which is just a 1/3. Negative divided by negative, it's a positive. And then now determine for which values of k will this q expression be undefined. Remember, the problem will be undefined if it's a fraction when you divide by 0. That means if this part can be 0 here, therefore this will be undefined. We are determining for which values of k will this q expression be undefined. It's when k minus 4 being equal to 0, it will make this to be undefined. Therefore, when the k value is equals to 4, then this expression will be undefined. Another way of asking the nature of roots, you are given the equation 4x squared plus 3x plus p equal to 0. Determine the values of p. P is part of that, for which the roots of the equation will be non-real. They are telling you that the roots will be non-real. So you start with your discriminant. Discriminant for non-real roots is when this is less than 0, being negative. So what is discriminant? Discriminant is b squared minus 4ac, less than 0. Remember, this is the value of a, the value of b, then this p will be the value of c then. So what is b? B is 3 squared minus 4a is 4, c is p, less than 0. Simplify 3 squared is a 9, minus 4 times 4 is 16p, less than 0, minus 16p transpose 9 minus 9. Now we are now dividing by minus 16 both sides. The minute you divide by a negative value, the inequality sign changes. The same applies as inequality, solving inequalities. And then this will be just a positive 9 over 16. So this p value must be greater than 9 over 16 to satisfy the condition. Okay, and then now we move to complex numbers. When you talk complex numbers, this is still your 50 marks grade 12. A complex number is a real number plus imaginary number. Imaginary is because it's having this I notation. This A is any number, real number. It can be an integer and so forth. This is the notation. Z represents complex number, A is a real number, BI is an imaginary number. Powers of imaginary numbers. If I'm having I squared, I can remove that I squared and write minus 1. The same applies if I'm having I can write that as the square root of -1. Those are the definition of the complex numbers. And then under complex number, we have conjugate. Conjugate, we apply them when mostly we are dividing the complex numbers. So if the sign of the imaginary number of a complex number is changed, we change only the imaginary number to create a complex. Look at this now. We are having this complex number. Look at the imaginary number there. The sign have changed from plus to a minus. Now it is now forming a conjugate. For an example, if I'm having 2 plus 3i, the conjugate for this one will be 2 minus 3i. Can you see? The sign is only changing on the imaginary part to form a conjugate. Now let's apply the conjugate. Now simplify to the form a plus b without using a calculator. Can you see that you are having 3 minus I here? This is the same as 3 minus I on the denominator. So we are going to take this minus 4 plus 3i and write this as 3 minus I here so that you don't get confused. So we are going to multiply by its conjugate in order to simplify this division. This will be 3 plus I. Remember, we change only the imaginary part. So we ensure that it's 3 plus I over 3 plus I, because multiplying by 3 plus I over 3 plus I is the same as multiplying by 1. Remember, 2 over 2 is 1, 100 over 100 is 1. So we are not tampering with the value of these binary numbers. So now we'll be having minus 4 times plus 3i multiplied by 3 plus I there. Also on the denominator we have 3 minus I multiplied by 3 plus I. So we end up with minus 4 times 3 is minus 12. Minus 4 times I minus 4i. 3i times 3 is 9i. And then 3i times I is plus 3i squared. Do you still remember that we said the I squared is equal to minus 1? So we are going to apply that. And then 3 times 3 is 9. These ones are difference of 2 squares. They will give us minus I squared there. And then now from here, grade 12s, we can add like terms. We are having minus 12 on top. And the minus 4i plus 9i, that is 5i. And then this one will be a minus 3 because it will be 3 times -1, which is minus 3. And then now this is 9 minus I squared is minus 1, remember? And then that is 5, this is minus 12 minus 3, that is minus 15 plus 5i. All over 9 minus minus 1 is 9 plus 1, which is 10. And then they said your answer must be in that notation. So it will be minus 15 over 10 plus 5i. We are separating the denominator. Each term is taking denominator 10. 15 over 10 in a simple form is minus 3 over 2 plus 1 over 10, 1 over 2, sorry, 1 over 2i there. 5 goes once and then into 10 twice. Then we are having minus 3 over 2 plus 1 over 2i in the correct notation that is expected of us. And then we have the Argand diagram. A complex number z is equal to a. Remember, this one is the original complex number. Can be represented on a complex plane. And that complex plane, we call it an Argand diagram. We used to call it Cartesian plane in functions. In complex numbers, we call it an Argand diagram. And the x-axis that we normally know, they represent the real part. And the y-axis, they represent the imaginary part of your complex. That means the a's will be on the x-axis and the b purple will be on the y-axis. And then a complex number za can be plotted on two-dimensional plane. Where a is plotted, I've already talked to that one. And the b will be plotted on the y-axis. Okay. And then now a represent the real part, b imaginary. I've already talked to that one. Then we bring in the r and the theta them. R is the modulus, is what we used to call the hypotenuse side on trigonometry. And then theta is the argument we used to call it theta on trigonometry. So under the complex number, they are just changing the naming of the letters. R is modulus, and then theta is argument. Okay, and then whatever was our x is now a, the y is now a b there. Now to calculate r, we use the same method. Is a squared, the square root of a squared plus b squared. Remember, we used to use Pythagoras, right? It was r squared equal to x squared plus y squared. So r was plus minus, or r was always positive, like that, x squared plus y squared. If one side loses exponent, we are expected to have a plus minus, but because we are talking radius, we'll only consider the positive solution. That is the same thing we are applying here. Remember, this a is represented on x, the b is represented on y. So we, instead of writing x, we put an a, instead of writing y, we put an a b there. Theta is an argument. Now grade 12, sometimes to calculate this theta now, theta, if it's in the first quadrant, argument, we are using that notation of tan theta. The theta is equal to arctan of whatever gradient. You still remember the inclination where we have m is equal to tan theta in trigonometry. In order to calculate the theta, we consider this arctan coming to the side. Okay, and then if it's in quadrant 1, it will be the arctan of b over a. If it's in quadrant 2, remember we are considering the reduction 180 minus. It will be 180 minus arctan. If it is in quadrant 3, we are considering 180 plus, because we are in this quadrant. So these values are indicating the quadrants. And then if we are in fourth quadrant, we are considering the 360 minus. Hence we are having that. But they are all using the arctan b over a. Okay? And then now we have what we call the rectangular and polar form. If we don't say polar, we'll say trigonometric form. And then this comes from the sine theta. Sine theta, remember, on SOHCAHTOA, we are talking b over r. So we leave b because b is the opposite, right? So we leave b and cross this r to sign here. Hence we have b equal to r sine. The same applies. R will cross multiply to cos. Then a will be equal to r cos. Then we take the original rectangular or the complex number, z equal to a plus ba. So we substitute a now with what? R cos theta. There we are. And then we substitute a b with what? R sine theta. There we are. And then from here we take out r being common there. We'll be left with cos theta and the I sine theta there. So by so doing, grade 12, we are creating a polar form. This notation now, we now call it the polar form. If it is not noted like that, they will say r is theta. It is still c for cos, and then I s for I sine. And then another one, the last notation is that one with a cap on it. So it's r, that's cap theta. It indicates the c's of theta there. And then now they say represent this on an Argand diagram here. So we must know this one is the a value. It is represented on the x. And then this one is the y value, is the b value, which is represented on the y. So now basically, if we are drawing this Argand diagram, you can see that a is positive 5 on x. And then the y is negative y on the y, and then this is the real and the imaginary axis. So now if we are coordinating 5 and minus 5, this will join here, and then now from the origin to that point, that is the Argand diagram for that particular complex equation. Okay, and then now they say express this in polar form. Remember, our diagram is in quadrant 4. Our reduction here is 360 minus. That means now if we are expressing this in polar form, we must find the theta or the modulus and the R value, modulus and the argument. And then now in this case it says theta will be 360 minus arctan of what? B. What is our B? That is minus 5 over 5. But remember, we don't consider this negative because it's showing us the quadrant. That will be 360 minus tan 1, which is 45. And then our theta in this case will be 315. And then now we need to find the value of R. R, we said, is going to be always positive, of which is the A value, 5 squared, plus the B value, which is minus 5 squared. And then this is give us as the simple set form, which is 5 square root 2. And then now the polar form for this one, it will be equal to, remember now, the notation says R sees theta. What is R? 5 square root 2. The series of theta, or you can write it as 5 square root 2 into cos 315 plus I sine 315. Okay, or you can write it 5 square root 2 with that cap, 315 inside the cap. And then this one here, it must be 5 square root 2 C is 315 degrees. So it's notation 1, notation 2, notation. It's up to you, grade 12, which one is easier for you. Okay. And then now solving complex equation. That means we are talking to the simultaneous equation of the complex numbers. So now we are solving for M, and N is 2 unknowns. So what you need to do, grade 12, you need to target your numbers now. In this case, we are having a challenge with that bracket. That is our starting point. We are going to say M is equal to 6i squared. 6i squared. Then we multiply. This is minus 5, 10, 15i plus 7 minus ni. And then now this will give us, remember 6 will be into minus 1. I squared is minus 1 minus 15i plus 7 minus ni. M is equal to minus 6 minus 15i plus 7 minus ni. Can you see I'm not changing anything, I'm just simplifying them. And then now we are having minus 6 plus 7, which is 1, minus 15i minus ni. So now if you concentrate on this one and try to find, do we have anything? This is the values that are having an I. On the left hand side, we don't have anything with an I. So now it is making M equal to 1 being the solution for M. And then this one, minus 15i minus ni, is equal to 0 because there is nothing with an I on the left. And then now remember, we concentrate only on the values, grade 12. That will be minus 15 minus n equal to 0. Therefore, n will be equal to minus 15. That is how we solve our complex numbers with 2 variables. Thank you very much, grade 12. This brings us to the end of today's lesson. This was brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. See you next time.